Welcome to Complexity Made Simple. My name is Paul Allen, and before we get into today's video, well, I'm just going to remind you the 3 books that are on sale. Drink tea and read the paper. If you're a green belt and a black belt and you want simple instruction on how to apply your skill, design of experiments for 21st century engineers, and finally a statistical process control for small batch production. They are all available from lulu.com and the links are in the video below. Welcome to Complexity Made Simple. My name is Paul Allen and the subject of today's newsletter is: what is Six Sigma and what is it going to do for your organization? Why should I be interested in this thing? So here's the subject. What is Six Sigma? Okay, now this is a response really to an email that I received from a client of mine. She's recently moved roles, so she's gone to a new company. She has a new role in a new company and she would like them to use Six Sigma. And when she mentioned Six Sigma to them, they thought that Six Sigma was the phrase was a dried up old buzzword from the 1990s and gave them no value whatsoever, which is amazing. And by the way, it's not the first time that I've heard someone go, yeah, Six Sigma's not for me. Yeah, so totally misunderstood what this is. What we're going to do is go through a little bit of the history. Where does it come from? And what is it really? And the first thing I want to address is the name, the buzzword. Okay, let's take Six Sigma as a phrase. And you know what we want to do before we do anything else? I want to take this away, because this is the phrase that Motorola gave to this subject. Let's take it away, because what it really is world class engineering. It's world class engineering. It's world class problem solving. It's world class production engineering and industrial engineering. It's world class design engineering. Now then, if I said, are you interested in being world class as a group of engineers? I'm sure at that point you'll be going, tell me more. Take the phrase Six Sigma away and replace it with this phrase right here, because that is what Motorola intended it to be, world class engineering. So I'm going to take you through the timeline of where Six Sigma comes from, where Motorola put it in the timeline. And by the way, we're going to go back not to 1985 or 1983 when Motorola started coming up with this this name and this phrase and this methodology. We are going to go right back to the 1870s, because that is where Six Sigma comes from. So we're going to draw the timeline. I hope I'm going to get this somehow to be in time. We'll see how we do. And we're going to go back to the 1870s. Why to the 1870s? Well, this is the point where the double-sided tolerance was invented. I mean, today we don't even give a second thought to the double-sided tolerance. It's just what we do. Every engineer just takes it as read that we have a double-sided tolerance. Back in the 1870s it didn't exist, and it was invented in Great Britain. What were the British trying to do? Well, we wanted to ship things around the world. We started shipping goods around the world, and of course big things that needed spare parts, like steam trains, for example. So you start shipping things like steam trains around the world, and then you need a spare part for it. You send the spare part out. When it arrives, it's probably taken 3 months to get to you. It doesn't fit, and it doesn't fit because we didn't have the double-sided tolerance. Everything was made by a tradesman. Everything was a skilled man, made to fit. They invented the double-sided tolerance. Now that didn't become worldwide as a standard until around about the 1920s, and in particular in the United States of America. Obviously they started to move as an industrial nation. They were making lots of newfangled things, putting telephone exchanges in, all kinds of things. The double-sided tolerance appears over in the United States, and now we have a problem. We need to make the machinery, the process, fit inside the tolerance. So suddenly we've got this problem. We need to understand the variability. Can I make my results fit inside those blue tolerances? And it's not as easy, you know, it's an easy picture to draw. It's not an easy thing to do technically, and it's especially not easy to do if you don't have any tools. So in the 1920s, and here's a book I'm going to refer to, Walter Stewart, Statistical Method from the Viewpoint of Quality Control. So you think Six Sigma's new, you think Six Sigma's the 80s. This is 1939 that this guy started thinking about variability and how it fits inside a tolerance. Now this is world-class engineering. This is knowledge that today is still valid. You are still trying to do this today. World-class engineering. Back in 1939 he started to develop this. Okay, so Stewart came up with SPC. Back in the 20s, he was the first person to look at the difficulty of getting processes to fit just regularly, every blow of the machine fitting inside the tolerance. So we go right back to the 1920s, and then the development starts. So now we've got various points in the 1950s, the 1960s, the 1970s, put that better, there we go, 1970s. And at each point things are beginning to develop. So the likes of, so this was Stewart back here. Of course in the 50s, 60s and 70s, what did we have? Well, we had Duran and Deming working in Japan, showing the Japanese how to implement the ideas of Stewart. And of course they were developing not just tools, this is a mathematical tool, SPC, but they were also developing management methods as well. The idea of understanding what the customer wants, quality from the customer's point of view, is very much Duran's strong point. Here's another book I'm going to refer to. It's the Quality Control Handbook by Joseph Duran. It was published back, I think, in the 1950s. I think this is 1950 this book was originally published. Let's have a look. What's the time? What year? 1951. 1951 this thing was published. Okay, so and in that book pretty much are all the things that Six Sigma leans on. The idea of what does the customer want, tools and techniques, more than just SPC, in order to be able to please the hell out of the customer. World-class engineering. So Deming and Duran. We've also got design of experiments appearing in engineering for the first time. People like Taguchi. People like Taguchi are using design of experiments. We've also got 1960s. You've got people like Shainin developing problem-solving techniques, component swapping, pairwise comparison, things like this. So you've got Shainin developing these techniques. And then we arrive into the 1980s. And this, on this timeline, is where Motorola appear at this point. Now bear in mind the 1980s. This is before the publication of things like the machine that changed the world, and lean became headline news in manufacturing. So Motorola are in trouble. They are losing market share and the business is not going well. The Chief Executive Officer asks his senior board, his senior team, what's wrong with Motorola? Why are we losing market share? And a voice pipes up from the back of the room and somebody says, our quality stinks. Big intake of breath. I think they're expecting the guy to get sacked. But instead of that, the Chief Executive Officer, what does he do? He thinks, okay, I'm going to go find out. So he goes and talks to the customers. Great thing to do, by the way. You should all do this. Go and talk to your customer. What do they think of you? He goes and asks the customer. What does the customer say? Exactly that. Your quality stinks. So what Motorola embark upon is an ability to fix their technical problems. So I said that this is world-class engineering. It's what Motorola intended it to be. Okay then, why is it world-class engineering and not something else? Because it's a technical problem they've got. They are making technical products at this point, radios, probably phones, etc. And their quality stinks. They need this to fix it. Now, why did they go to such great lengths? Well, initially, they set themselves a challenge to reduce their defect rate by 10 times. And then somebody in the organisation said, we really ought to benchmark the competition. Is 10 times enough? And what they found out was the true scale of their problem, because they were 1,800 times worse for a defect rate against their competition. And suddenly they realized they needed world-class engineering. Now this is why Six Sigma is called a business strategy, because for Motorola it was a business strategy, and it was exactly the right business strategy for their problem. Yeah, so their problem was quality. They needed world-class engineering. So Motorola need world-class engineering. They've got to be 1,800 times better than their current defect rate. This isn't just a simple 3-month project. Let's be 10 times better. This is not something that's just one process. This is company-wide. All of their processes need to be changed dramatically. So they know they need world-class engineering. Now, does this happen instantaneously? No. Is all of this information just sitting in front of them? No, it's not. They spend the next 5 years. In fact, at one point, they engage Shane in the company to try and help them to solve this problem. And eventually, they reject Shannon's methodology and decide it isn't what they need. But they spend 5 years looking at all this great stuff that comes back from Stewart. By the way, all of these guys, Deming, Duran, Taguchi, they all worked with this guy. Yeah, it all stems from the thought process of Stewart and the fact that he's trying to get processes to fit inside tolerances. And it is all about variability. He's the first guy to talk about it, as variability is important. So they spend 5 years looking at all these tools and techniques, looking at the fact that Duran is saying, what do you need to do? You need to talk to the customer. Go find out what the customer wants and deliver what the customer wants. They've done that. They need this technicality. They need this defect rate. They've gone and looked at all the tools and techniques, and it's only at that point that they end up in around about 1985 in creating the agenda and the name. Six Sigma. Now, what is Six Sigma? It's world-class engineering. If you look at what's in this book, by the way, Quality Control Handbook, as I mentioned already, 1951 this was published. Already, back in 51, Duran is telling you how to do proper design work. He's already outlined, design of experiments, by the way, is already in this book in 1951. Six Sigma is not new. It's not a buzzword. It's just the name given to world-class engineering by Motorola in order to solve their particular problem, that quality stinks. Now, should we all go and do Six Sigma the way Motorola chose to go at it? Not necessarily. You have to decide if you've got real technical problems. If you're a technical manufacturing company, the tools that are in Six Sigma help you to get better answers faster. Why would you not want this stuff? It is world-class engineering. Some companies, it's not what you do. Lean is the real approach. So if you do simple assembly work and things like that, if you're a company that's putting stuff on a shelf, storing it for people, then selling it in a catalogue, and you're just moving material around, Six Sigma probably isn't your tool of choice. It's probably not your weapon of choice. Lean is going to do great work in that type of environment. But for Motorola, they needed world-class engineering because that was their problem. It was heavily quality related. So key point, decide what your problem is. Decide what the world-class way of sorting it out is, and then go and sort it out. But if you are a highly technical company, you are machining things, you have heavy technical processes that are difficult to understand, difficult to control, Six Sigma is the world-class way of doing it. Surely you want to be world-class, don't you? Because that is what Six Sigma is really all about.